have very professional people who test everything. Now Eric's going to get a very hard time, but it looks like he's able to manage that case for you. It's good to be in Stanford, you know, so skilled people here. Look at what speed that works. I'm not going to say anything additional because he has it fully under control there. I'll give you already a microphone. Lovely. Look, these are professionals here. Welcome.
Thank you. My name is Igor Alvarado. I work with the National Instrument. We're based in Austin, Texas, and I basically work with academic research institutions around the country in the US. And basically I would like to show you an application we developed originally for one of our customers. It started in a different industry, and then we found that it could be used in different industry for what we call non-contact hotspot detection. And this is using a technique called beamforming, using an array of accelerometers or an array of microphones. Basically, both are piezoelectric type sensors, and also using cameras, digital cameras, standard cameras. So I will show you an example in which we are using 32 microphones simultaneously with a camera in order to detect a hotspot in the blades of a windmill. That's one application in which we use this, and also I will show you an example of a compressor, an air compressor, in which also we apply the same technique. As you can see, basically we are talking about a number of microphones, and each one of them, they are composed you arrange them in a specific array, and you can have as many channels you can handle. We have an application in which we have 1,000 channels simultaneously being analyzed with a researcher at a university. So you build your beamformer using that. In the example I was talking about, these customers needed a way to do hot spot detection without installing physically sensors in the structure because of the difficult access or different reasons they have for that. And if they had something that could show them where the problem could be, then they can take a second step and make the corrective action that was needed. And in this case, you can see on the left side, they use a microphone array. That microphone array is basically composed of 32 channels. Then you use an air acquisition device, that's a compact radio system. And then, as you can see on the right side, we have a windmill in which you can actually see the noise generated by the blades in real time, synchronized with the image we are capturing from the windmill. So, as you can see the system on the table on the left side, this is an actual test we did. This is one of the national labs that is doing this type of testing. And you can see on the right side the microphone array pointing to the windmill. Then we synchronize the signals from the microphone arrays with the video signal from the camera. And doing that, we can have an overlay on top of the image showing the hotspot on the windmill blades. So as you can see in this sequence, we actually were able in real time to identify different hotspots. These are for different reasons: too much speed on the rotor, or the pitch, or the angle on the blades, or some kind of a fracture or crack on the blade. Something was generating the noise. So that's the idea of using this technique. So as you can see, basically they could see this in real time. Let me show you the video of the actual application, and you can have a better idea of what I mean. Okay, so here you will see the actual video of the windmill running, and actually we are getting the noise using the microphone array. The more microphones you have in the array, the more resolution will have your sensor, your acoustic camera. That's how we call it. And you can see on top of that the overlay using the image. So basically, they know where the hotspot is. They know even which blade is causing or has the potential problem. So now they know where to attack the problem. So with that, I will finish my presentation. There is
very good. Which has not been shown too much, but I think which is very, very efficient, specifically for that type of structure. Right, the next one.